Hey there. So in recent videos, we have been graphing in slope-intercept form. We've understanding what slope is, that ratio of rise over run. And in this video, we're going to look at some application problems. Now, in every application problem here, we will have an equation with it. In a couple videos in the future, we will be looking at how to actually write these linear equations. But for these applications, the equation is going to be given to us. We just have to understand the different parts. Okay, so in this first example, Tanya has $100 saved in a bank account. She got a job working at Starbucks and earns $50 a week. She decides to put the entire paycheck into her bank account. This situation can be modeled by this equation. So that's an important part. M of x equals 100 plus 50x. That part right there is going to be very important. Okay? So this next part is going to tell us what each part means. M of x is how much is in the account. So this is the money. And x is the number of weeks that have passed. So first, we got to understand what these numbers are. So the initial amount in the bank account, initial is going to be the beginning. Okay? So the beginning amount is $100 because that's how much she has saved so far before she starts working at Starbucks. The rate at which the account is increasing. Okay, so the rate, remember, that is the slope. That's the slope. So the rate is $50 per week, or $50 in 1 week. So something that might be helpful is to rewrite our equation in slope-intercept form. So m of x is equal to my slope, or that rate, which is 50. So 50x plus where I begin. Oops, for color's sake, I'm going to go back just so that the colors match. The rate was 50. So 50x plus my initial, or where I begin, 100. So I'm just going to rewrite that in slope-intercept form. All right, so to help us graph, we're going to fill in this table. So if she has worked 0 weeks, how much money does she have saved? Well, that's going to be the initial amount, because remember, these are all coordinate pairs, so 0, 100. Okay? If she works 1 week, how much money is she going to have? 150. 2 weeks, I plug in 2. Okay, so just so you see what we're doing here, we're evaluating my m function at 2. So I'm just going to plug in 2 for x, and when I simplify that, that's 200. Okay, you can see we're just going up by 50s for each week that this increases. All right, so because the weeks are just going in order, I can just make this go up by 50. All right, and so now I'm going to go to the next slide just for room. I want to graph this line. And so how I'm going to graph it is that I am going to take this, and if you put it in slope-intercept form, that might help. Okay, I need to label this graph. So what I'm going to do, what does the x-axis represent? What does the y-axis represent? So I made my graph a little smaller just so that this would all fit. The x-axis is being represented by the number of weeks, because remember, your x-axis, that's your input. That's what you're plugging in. So these are the weeks, and so this starts at 0, and I'm just going to go up by 1s. 9, 10, I'll stop there. The y-axis, what do I get out? What's my output? Well, that's the money in the account. So I'm just going to call this money. And I gotta pick a value, or I gotta pick a scale that's going to make sense here. And so, just gotta make that a little nicer. Okay. I start at 100. And I go up by 50 each time. So I'm going to have this scale be by 50. 100, 350, 400, so on and so forth. So now I just need to plot my points, okay? At 0 weeks, she has $100 in the bank account. After 1 week, it's $150, so on and so forth. So if I just plot all these points and then if I connect the dots, boom. Okay, that is a graphical representation of this function. So, what does this, so that takes care of part D. We graphed the line, we've labeled our graph. Now we just need to answer some questions. The first of which is, what does the slope represent? So the slope value is 50. So m is equal to 50, or 50 over 1. All right, and that slope is saying she earns $50 per week. Okay, that's just the rate at which she's earning money as her money increases. Okay, and then what is the 0.4 comma 300? Well, remember, 4 comma 300, that's in terms of x comma y. The x is the number of weeks, and what is the y? The y is the output, that's her money. So after 4 weeks, she has $300 saved. I want to be specific on a question like that and actually use the numbers that are in the coordinate and tell me what they mean. All right, so I wanted to work out that example for you. I have 2 more examples for you to complete. Okay, so make sure you practice those. Ask any questions along the way. I'll throw up the work and you can check that for. Okay, so there you'll see my work for your first practice problem. Make sure your graph looks like that. Make sure you've labeled your graph. And most importantly, I'll say most importantly, you got to know what the slope represents. Okay, you have to be able to know what that -3 value is. So it might be helpful to rewrite this in slope-intercept form so you don't mess up any of the parts. Okay, so that's that first practice problem. Make sure that's good to go. And then for your last one, complete this. Okay, so in this one, the reason this problem's in here is you'll notice that your point values that you are putting on your graph on this scale aren't nice, but you can still graph it, okay? So your y-intercept is right around, or is 10, okay? But 10 is in between 9 and 12, probably a little bit closer to 9. And you go up 3 over 1. Okay, if you plug in 1, you're going to get out 13, so that's why that's just a little bit above 12. You can still graph that, okay? So just make sure you are understanding all those questions. That's going to wrap up this application video. Make sure you practice these skills. Ask any questions as they come up. All right, have a good one.